field is there. Only rotational motion. What is the EMF induced between these 2 points? If a ring rotates in a uniform magnetic field, will there be any EMF induced in it? I'll come to the problem question later on. First, let's analyze here. Nothing is there. B bar into the plane. Let L be the length of the ring. This is a ring. I'll just rotate the ring about an axis passing through its center perpendicular to plane with an angular velocity omega in a uniform magnetic field, and now B bar perpendicular to plane of the ring and parallel to axis of the. Will there be any EMF induced in that? Will be zero, no? No EMF will be induced. So what is the rotational effect on the ring? What is the rotational effect on the ring? Though due to rotational effect, there won't be any EMF induced. The similar idea. Only due to translative motion it will come. Please do understand this is the idea of the problem. The ring is rotating about an axis passing through its center perpendicular to plane. B bar is perpendicular to plane of the ring. Then no EMF induced in the ring. Come for this problem. They're having rolling motion. So due to rotational effect, there should not be any EMF, only due to translative motion. And only due to translative motion, what we do? We replace the ring. If only due to translative motion, there's everything. So how do it will behave like a cell, no? So what should be the EMF induced? V 2R into this one. So this will be one cell. B bar out of the plane velocity. So this should be the this is the ring Q. There's a point Q. Here B bar out of the plane, B bar out of the plane. So this will be the velocity. Now what should be the EMF? What is the length? 2R, no? So this should be BV 2R or 2, and they should be BV 2R, and they should be B 2V. This is 4R. So 2V, B 2V, 2R. Diameter will become 4R. I am replacing this ring with a 2 rods, and the EMF in the 2 rods is what I'm showing like this. So this should be again. It's asking potential difference from X to Y. So let me proceed like this. Vx, is it polarity okay? How to decide polarity? B bar velocity. B bar out of the plane. I think first the left rod I'm bringing polarity. B bar out of the plane velocity. So this end should be positive. Yeah. For this ring, B bar out of the plane velocity. So this end should be positive. So I'll write it Vx minus B 2V 2R minus BV 4R minus Vy equal to 0. No potential difference is set up. So due to rotational effect, no EMF. Due to questions of this kind, very important for exams. Due to rotational effect, no EMF. That one means if a ring, if it is having uniform pure rolling. Let me just describe the basic things. So there's a ring which is having a pure rolling, and another ring let me introduce forward slipping, backward slipping, all. V equal to R omega, V1 greater than R omega, V2 less than R omega 2. Forward slipping, backward slipping, pure rolling. And B bar is everywhere into the plane. What about EMF induced in all three rings? About what point? About point XY. Eight BVR minus negative of negative. Okay, sir. Yeah. Yeah, calculation mistake. Thank you. This one. Check it now. What about VXY in all the cases? Ring 1, ring 2, ring 3. Anybody? VXY in all the cases. Will it be same or different? Due to rotation motion, no EMF induced, no. So therefore, V1, E1, E3 should be equal to velocities are different. Let me put like this. I'll generalize it now. This will be BV into 2R. R is the resistance of the ring. Is it okay forward or backward? Irrespective of that, due to rotation motion, there won't be EMF induced. Only due to translative motion. Please just be careful in exams. They'll try to test with all application part. Why two cells? Because this ring